Now factoring is the simplest way to solve any quadratic equation. But not all quadratic equations can be solved easily by factoring. So even though we know that factoring is the best way to go, you may not be able to use factoring on all types of quadratic equations. So in this first section, that's what we are going to look at, is look at one of the methods of how to solve a quadratic equation. And the first example we're going to talk about is what we call as the square root property. So let's start with equations of this form. We have equations of the form where you have x squared equals k, where k is some positive number. So to understand this method better, let's say we have this expression m squared equals 64. So if we were solving this in a traditional way, we would go ahead and bring our m squared minus 64 on one side and 0 on the other. Now you can go ahead and factor this side out, and that will factor into, of course, using difference of squares. This will give you m plus 8 and m minus 8. Okay? And then applying your zero factor property, you can say m plus 8 equals 0 or m minus 8 equals 0. Solve each one of these equations and you end up with m equals negative 8 or m equals positive 8. So of course that tells us that our solution set for this equation is going to be negative 8 and positive 8. Okay, and again, if you want, you can go back and check your solutions in the original equation and see if both the solutions will work, and they will. Now you could have also tried and solved this same equation, m squared equals 64, using a different approach. So in this case, let's say we have m squared equals 64. Now what you could have done is, basically we are saying some value squared gives us 64, right? We're saying m squared should be 64. So again, you can try and see what values squared will give us the number 64. So we can start by taking the square root on both sides. Okay, so go ahead and take the square root. And we know, we talked about this earlier in chapter 10, where we said when you take square roots, you can end up with a positive or a negative root. So when I do that, I end up with m equals positive or negative square root of 64, we know, is 8, which is the same thing as we had got earlier when we factored this expression and tried to find our solutions. So you end up with, again, the same answers as we did earlier. The solution to that equation could be negative 8 or positive 8. Again, remember, anytime you take square roots of numbers, you can end up with a positive, or what we call as the principal root, and you can also end up with the negative root. So that is another method that you can solve these quadratic equations of this form by, and that is what we like to call as the square root property of equations. So let's go ahead and see what that property is. Now it says if you have an expression of this form, x squared equals k, and k is a positive number, then you can end up with the solutions as x equals square root of k or x equals negative square root of k. Okay, so your solutions will be the negative square root of k and the positive square root of k, which is what happened here. In this example, you took m squared equals 64, you took square roots of 64, which gave you positive and negative 8 as your answers. So let's go ahead and apply the square root property of equations to a couple examples here. We'll go ahead and look at our first example. This one is x squared equals 225. Now they're saying use the square root property, solve the equation, and also write the radicals in simplified form. So just like our square root property says, let's go ahead and take a look at it. It says anytime you have a positive number, k, you can set it up as x equals square root of k or x equals negative square root of k. So let's try and do that here with our x squared equals 225. So we'll go ahead and say, x can equal positive square root of 225, or x can equal negative square root of 225. Okay, just like what your definition for the square root property says, we're trying to do the same thing here. And what will be the square root of 225? And of course your answer should be 15. So your positive root will be 15 and your negative root will be negative 15. And again, if you want, you can go back and check your solutions, and your solution set is going to be negative 15 and positive 15. Alrighty, let's look at another example here. You have x squared equals 54. We want to try and do the same thing here, is just like we did in our first example. You will end up with x equals square root of 54, or x equals negative square root of 54. Now 54, as we know, is not a perfect square, so you will have to simplify that radical, and we can write 54 as 9 times 6. Again, the reason we write this as 9 times 6 because 9 is a perfect square, and that will give us square root of 9 is 3, and 6 will stay inside the radical sign, and you will end up with 3 times square root of 6 as the positive root. For the negative one, you'll do the exact same thing, simplify 54, which will give you 9 times 6. But this time you will have that negative on the outside. So again, square root of 9 is 3, and square root of 6 will stay inside the radical sign. And again, if you like, take the two solutions and put it back into the x value and check your answers and make sure that you end up with a true statement when you use both of these solutions. And again, we can say that your solution set is negative 3 square root of 6 and positive 3 square root of 6. Okay, so in this case, you can see that you ended up with a radical as part of your answer because we couldn't completely simplify square root of 54, so we try and simplify it as far as we can. Okay, let's look at a couple more examples. Now this one here, as you can see, is 3n squared minus 72 equals 0. So we want to try and put it in the form of x squared equals k. So you want to try and get the squared term by itself on one side and every other number on the other side. So the first thing we start by doing is moving the 72 over to the other side, and you end up with 3n squared equals 72. Okay, but we still don't have the squared term by itself. You can see that we still have that 3 over there. So to get rid of that 3, we divide both sides by 3. And of course you will see that that leaves you with n squared equals, and 72 divided by 3 will of course give you 24. Okay, now this is in the form x squared equals k. You have the squared term by itself and the constant term on the other side. Now we are ready to go ahead and set this up. So this will be n equals square root of 24, or n equals minus square root of 24. Again, we know 24 is not a perfect square, So we will go ahead and simplify this radical, and that will be, let's see, 4 times 6, because again 4 is a perfect square, so that will end up giving you 2 square root of 6. And of course, if you try and do the same thing here, you will end up with negative 2 square root of 6. So the only difference between these two values is that one is positive, one is negative. And again, you can say your solution set is going to be positive and negative 2 square root of 6. So if you want, you can write it as two separate answers like we did in our earlier example, where we write this as negative 3 square root of 6 and positive 3 square root of 6. Or you can just write it as plus and minus 2 square root of 6, and it just by looking at it, we know that we have two parts or two answers to this equation here. All right, we'll look at one more example, and then we will move on and see a different type of application. So we have 2z squared plus 7 equals 61. Just like we did in example number 3 here, you want to try and get the square term by itself and move everything else over to the other side. So of course, our first step is going to be moving the 7. Okay, so that will give us 2z squared equals 61 minus 7, which will give us, let's see, 54. Okay, and then just like we did earlier, we want to get rid of that 2 on our left hand side. So divide by 2, and you end up with z squared equals 54 divided by 2, which will of course give us 27. All right, now we're ready to apply our square root property, which will give us z equals positive square root of 27, or z equals negative square root of 27. Again, 27 not being a perfect square, we need to try and simplify this expression here. So we will end up with z equals, we can write 27 as 9 times 3, 9 being the perfect square, and that will give you 3 times square root of 3, because square root of 9 will come outside as 3, and this 3 will continue to stay inside the radical sign. So in the same way, you will do the negative root, and you end up with negative 3 square root of 3 as your answer. So again, go back and check your answers to make sure that these solutions will work for your original equation. And again, your solution set will be positive and negative 3 square root of 3.